Well, hey everybody, and welcome to the EcoCast by Actual Tech Media. Our topic today, supporting and enabling modern applications. Now, this is one of those cool topics that kind of has the feel of, okay, and not to get overly dramatic about it, but it kind of feels to me like the universe in the sense that it is constantly creating the space that it fills. Modern application environments are evolving and inspiring new solutions around them. So containers, Kubernetes, and other technologies are scaling, and then that expands the reach of the applications, which then requires and enables more complex and robust environments, and around we go again. So needless to say, it's a pretty cool topic, and there is a lot to cover. Luckily, we will be joined today by some amazing humans from Rapid7, Pure Storage, and Zerto. These experts are here to help us explore innovative new tools to help you transform your modern application environments. Now, if you have not joined us for an EcoCast in the past, a very special welcome to all you first-timers out there. Actual Tech Media created the EcoCast and the MegaCast series to help educate IT professionals like yourself on the latest innovations and trends in enterprise technology. These webinars are designed to get you the hottest insight, up-to-date information efficiently from the comfort of your home or office. MegaCast and EcoCast allow you to pose and answer questions, to connect with other experts in your field, and to help you solve your most pressing technology challenges. Now, before we get into our sessions here today, there are a few things that you should know about this EcoCast. Okay, so if your eyes went immediately to that prize tab, I get it. Hang tight. I'm going to come back to that in just a second. But first, I want to draw your attention to the questions tab in your webinar console. If you have not already said hi, I saw a couple people. I saw Singapore in there, Vermont, New York, California. Say hello. Get to know your neighbors. Connect with the community out there. The questions console is also a great place to let us know about any technical issues that come up today. Knock on wood, of course. I do want to remind you that a browser refresh is probably going to fix any of the usual issues that could come up. But if not, if they're particularly persistent issues today, just shoot us a message in that questions tab. The Actual Tech Media team is there to support. Most importantly, though, that is where we want you to ask questions. We want this to be an informative and engaging webinar, so please do make sure to get your technical questions in. We've got lots of experts here to help answer them. Now, not only will the team members be responding to you during the live webinar, we will also have a dedicated Q&A session at the end of the presentations. And if we don't get to your question during the live webinar today, don't worry, because the awesome humans from Rapid7, Pure Storage, and Zerto are going to be following up with you afterwards, so you will get answers to those. Okay, now you see that little social icon there. That's there to remind you that we think all good things should be shared. So today when you get that little brain tickle or something pops into your head that seems pretty fascinating, make sure to share it with your friends. You can use that Twitter button that's right there in your audience console. The hashtag for today's webinar is automatically going to be added to your post. Okay, so while we're exploring the audience console, one last thing to point out there, right next to that questions tab, you can find the Handouts tab. Awesome collection of resources to go along with the webinar today. Some great takeaways. So make sure you click around data sheets, white papers, solution briefs, and more. Start exploring, save those resources for after the webinar today. Now, if we haven't met already, my name is Jess Steinbach. I'm with Actual Tech Media. I'm so excited to be your moderator for this EcoCast and to join in this really important conversation with all of you today. Okay, I said that we'd come back to prizes, and I meant it. So we do have 3 $500 Amazon gift cards that we will be giving away today to 3 lucky winners. Now, of course, you must be in live attendance during the webinar today to qualify, and you must meet all of the Actual Tech Media prize terms and conditions, which you can find if you go back to that handout section, scroll on down to the bottom, you'll find the full T's and C's for you there. So go ahead and check that out. Also, I mentioned how much we love getting your wonderful technical questions. So we have an additional prize for all you insightful and inquisitive folks out there. Today we'll be giving away a $50 Amazon gift card to the best question asked in each of our sessions. And we're going to review those after the webinar, which means that even if your question does not get asked out live, there's still a chance to win. Now, I've got a few quick little reminders for you up on the screen, but again, full T's and C's in the handout section for you there. Again, just a reminder that all winners are required to submit an IRS Form W-9 to Actual Tech Media, and you can find the rest of those in that Handouts tab. Okay, so if you are a winner here today, I'm going to remind you that you have the option to donate the value of your prize to one of these selected charities here. Thanks to some really generous prize winners on previous Actual Tech Media webinars, we have donated thousands of dollars to these wonderful charities. And if you are a winner today and you'd like to get involved, please let us know because we would love to help make that happen. All right. Now, we do want to connect with you on social media. We're glad you're here today. We want to keep chatting with you, so make sure to find us on Twitter and LinkedIn. You can also find us on YouTube. We have so many incredible on-demand videos for you. So if you're all fired up after the webinar today, you want to keep learning, great. Head on over to the Actual Tech Media YouTube channel and start clicking through some titles there. You can also find some great content from us on LinkedIn. And if you have not visited gorilla.guide, today is the day. Go head on over there. Honestly, some incredible resources for you there. You get access to free enterprise IT books authored by top industry experts, so you can stay up to date on all these trending enterprise technologies and innovations and solutions. The books are completely free. They're going to work on your Kindle. They're going to work on your mobile device, so they're really easy to transport. You can download all these exciting resources again at gorilla.guide. There's a link in that Handouts tab for you as well. That Handouts tab, very handy. All right. Now, we have, and I've mentioned this before, we're fans of yours. We like you. We think you're great. We want to get to know more awesome people in your community. So another cool way to win a prize and share awesome things with your friends is to refer an industry friend or coworker to the Actual Tech Media webinar series. You're going to find a link to do that right in that Handouts tab. So head on over there and check that out. You're also going to get redirected at the end of the webinar. Now, I do want to promise you that we are not going to spam your friends or coworkers. Nobody wants that. We will send them an invitation to a list of upcoming webinars. Now, if they don't respond, we're going to give them one tiny last little wave, hello, and then that's it. And both you and your coworker or friend are entered to win a $300 Amazon gift card. We hold those drawings every month, so make sure you sign up a friend. Lots of cool content for them, and possibly the chance for both of you to win a $300 gift card. Easy win right there. Okay. Now, we like to throw in these little polls sometimes because, A, I want to make sure you're awake. I want to make sure you're paying attention. We're starting out our EcoCast. It's the morning for some of us, afternoon for others of us. Whatever time it is, head on over to your computer screen right now and answer this poll for us. What we're wondering is, if somebody asked you to describe your role in your organization, high level, what would you say? Would you say that I work in tech? Would you say that I work in IT? If it's neither of these, or you feel like you want to kind of delve in a little bit more, please do feel free to answer in the questions tab. We would love to know where you kind of see yourself. Again, just kind of getting to know our community a little bit better. And this is an interesting one, I think, for a lot of us. Do we say tech? Do we say IT? It means something slightly different to everybody. Okay, well, thank you to everyone who filled out that poll. Clearly, you have all had your coffee this morning. Early test down, and we can keep moving on with our session here, because up next, I am so excited to introduce you all to our keynote speaker. And now I'm sure actually a lot of you don't need an introduction here because you've probably heard from Howard before. But Howard M. Cohen, Senior Resultant, I love that, is here today to kind of talk to us about supporting and enabling modern applications. Howard, I always learn something new and exciting from your keynotes. I'm sure today will be no exception. So without any further ado, I will hand the platform on over to you, and let's get this EcoCast rolling.
Hello, I'm Senior Resultant Howard M. Cohen. I'm here to talk to you about supporting and enabling modern applications. Today's word of the day is cloud native, because today's modern applications are designed to be completely cloud native. Enabling these modern cloud native applications begins with what? A cloud. And of course, we have a cloud. Okay, along with that cloud, we're going to be developing software in the form of microservices, each one designed to do a specific thing that contributes to the overall program. These microservices will be packaged in containers that will move freely across whatever cloud services you're using, anywhere they may be located. We'll also have our development and operations teams working closely together to develop the software, deploy it to the users, deliver it, then get the feedback from the users back to the developers so they can create the next iteration of the software, the next improvement to the software. By doing this over and over again, we achieve continuous delivery with the hopes of achieving continuous improvement of the software and the products that result from the software. Now, lest you think that that's all we need to create these modern cloud-native applications, there's more. There's a group of backing services that'll be required. Orchestration services to move these containers where they need to be to do what they need to do. Management and monitoring services to make sure everything's working properly. Storage and streaming for all your data, much of it in the form of document and relational databases. Message brokers to keep in touch with everything that's working together on this network. Distributed caching and analytics. And of course, security services to make sure that all of the data and the operations are protected. That's a lot. And yes, it's a lot of power. This is a good time to remember that, as Uncle Ben said to Spider-Man, with great power comes great responsibility. We'll come back to that in a few minutes. What did software look like before? Well, basically it looked like a big block of code, kind of like this. We refer to this today as monolithic programming, where everything the program did was written into this one big block of code. You then ran it so it said, okay, do this, then do this, then do this, and if this is true, then do this, otherwise do that. And once in a while, let's look for any input from the user to see if they need us to do something differently. That was what monolithic software basically looks like. Now, the good news is this is all one program. It's all in one place. It sequentially executes each command. From an operational standpoint, it's only one executable to run. That's good. But it's also one executable to fail. And that's where we start to run into a problem, because if anything goes wrong in a monolithic program, that could bring the entire program down. Bringing the entire program down will have all of your users sitting around and twiddling their thumbs, which is not a good place to be. So this is not an optimal way to proceed. Okay, well, instead of our monolith, it's just falling down to meet us, we're going to create our software in the form of microservices, each one designed to do a specific thing that contributes to the overall program. Not one big block of text or one big block of code, but small little blocks of code that all work together. These microservices are put into and packaged into a container. Along with the microservice are all the resources it needs to do what it needs to do. Nicely contained in this one little package that can be moved anywhere at any given time. Now, some good news, multiple containers can run simultaneously, all accessing their resources as they need to, all doing what they do. Also, these resources may reside anywhere in the cloud, whatever cloud data center you need them at. So that's handy. Also, microservices and containers can run anywhere in the cloud, on any data center, any server, wherever it's best for them to be, using separate runtimes. So there's tremendous flexibility. The thing to remember is that containers are created as they're needed. They don't just sit around in storage anywhere. They're created as they're needed. Sometimes a bad thing can happen. A container can come out flawed or broken. And if that's true, well, we don't worry about it. We simply discard that container. It's gone. And a new one is reinstantiated in its place. Nothing else stops happening. No other operation is affected. It's completely decoupled from everything else. This broken container is gone, and it's in its place is one that works. This means we have to look at our resources in a very different way. We used to look at our servers and our storage kind of like our pets. If something went wrong with them, we nursed them back to health. We repaired that. We kept them well fed and well taken care of. Now we simply discard and throw away, kind of like cattle. Just when you need it, you got it. You need another one, get another one. And that's how resources are put to use in today's applications. So here's where we come back to great power leading to great responsibility. Also, with great granularity, as we've seen in these small microservices, comes great horizontal scalability. You can just keep adding and adding and adding, scaling out instead of scaling up so that it's broader and easier to use. I mentioned that these things are loosely coupled. The fact that one fails doesn't bring anything else down. That leads to great resilience. This software will just keep running. We need to remember, though, that with this great agility that we now have, there's a need for great logging. If anything does go wrong, we're going to want to be able to trace back to figure out where it went wrong so we can correct it. So it's important to have extensive logging in your management schema. With isolation of each individual operation will come the need for great coordination or orchestration. So we're going to need to be able to manage the movement of all of these different moving pieces at all times. Bottom line, with microservices and containers comes a totally made for the cloud modern application. Totally transportable, very lightweight. So with cloud native applications comes the need for purpose-built storage and purpose-built security, a purpose-built infrastructure that will support all of this and be manageable. And that's what you're going to hear about during the course of the rest of today's presentation. Thank you.
Oh, thank you, Howard. What an interesting presentation. I love those takeaways. And hey, any excuse to quote Marvel is a good one. Okay, so I'm very pumped up now to jump into our sessions. I think Howard really set the stage for us really well. But before we do that, I want to get an idea from you all. What's the time frame that you have in mind for adding new or updating existing IT solutions at your company? So in this case, we're looking at solutions around modern applications. And really what we're getting at here is just kind of, are you looking to make changes in the very near future or a little bit distant? And actually what I'm seeing from a lot of you right now, the results coming in, it looks like there's a lot of not sure's, and that's awesome. I really like to start an EcoCast there because what that tells me is that you guys are doing some research in advance. You're not really sure maybe what you need. You're not really sure exactly where you're going or what time you want to get there, and that could maybe feel a bit chaotic, but I think that's a great place to start learning and asking questions, and that means you're going to get some great info today. So on that note, let's get to some of that great info. All right, so it is my pleasure to introduce you all to our very first presenter in today's EcoCast, Dane Grace, Senior Product Manager at Rapid7. Dane, thank you so much for joining us. I know that our audience is pumped up, ready to get started on this EcoCast. We've got a lot of great questions kind of bubbling in already, so this is going to be a great day. Dane, I'll hand things right over to you.
Well, thanks for tuning in. So one of the challenges I've noticed, and I've seen increased interest or even actual movement into not only sort of the cloud infrastructure space, but containerization and by extension Kubernetes. But the problem is, the thing that I'm hoping to tackle with this talk is I talk to security teams and they say, hey, my organization is moving to a Kubernetes deployment, be that a publicly cloud-hosted instance of it or a self-hosted instance of it, and they say, I need to secure it. to which I reply, there is a lot of it there, and we need to talk about how we're thinking about that and how we're addressing that. And so that's sort of the high level of what I'd like to go through in my talk. Before we start, I just wanted to go through some terminology. I'm going to be throwing terms about, and I want to make sure that we all are sort of on the same page and using the same vernacular here. So what is a container? It's a standalone self-contained package of software that packages all of its codes and dependencies so the application runs quickly and reliably from one computing environment to another. Basically, I like to think of it as a sort of a cooler full of all of the things, all of the ingredients that you would need to have an app run in sort of a deployed environment. And you know, we've had these server stacks that work great, right? You know, you have a server with a web server that runs an application. Why are we changing this? And the reality of the matter is the overhead in deploying and maintaining those environments can be cumbersome. And for anyone that's been a developer, when they know that when they jump on a project, your first day to most of a week is just setting up the environment, right? Making sure that your dev environment has the proper web server configured the right way with the proper database server, et cetera, et cetera, et cetera. With containers, you have the small container that runs on a common runtime. You could literally hand that package of software to a developer. He could plug it into his machine and it would just run. So portability is one of the big pieces, and standardization, right? Once the container runs, it'll always run. You don't have to deal with weirdness between environments. So you get portability, standardization, and quick uptime, as well as scalability, because you can spin up multiple instances of the same web app relatively easily. So digging into Kubernetes, again, Nick touched on this, but it's just an orchestration environment. It's a general computing environment for containers. So you can plug your container in, and in an automated fashion, Kubernetes will stand those containers up and run those, oftentimes behind a load balancer, because one of the main really value props to Kubernetes is scalability. And we've spoken at this multiple times in this session thus far, but really Kubernetes provides that, again, air quotes, infinite scalability. And so here's my story or my analogy to kind of encapsulate the value prop of Kubernetes. So I am running a web store. I sell books, mostly around the container security space, and I have my web store running on this custom coded environment that's running on containers, and it's just running on a host, and I have one container for everything, and it's just great, and everything's happy. And I hum along at about 100 visitors a day, and my app runs fine. Except Nick mentions me in a webinar, and all of a sudden, by the way, it's also Sunday before Cyber Monday, and my scale goes from 100 visitors a day to 100,000, because Nick has that reach and power. So I have two options here. I could either let my site die and go up as it can handle the scale, or I could sit there and manually spin up additional instances of my website, put it behind a load balancer, let it run, and for the week or so it takes for the load to scale off, for my traffic to die down, and then I have to go in and start killing, either let it all run and build up costs, or start killing nodes and descale my website in a manual manner. With Kubernetes, as sort of the alternate version of that story, my website would hum along. As it scaled up, my Kubernetes would automatically spin up additional instances of my website, all behind a load balancer, so everything's getting routed. It would, and let's say I have infinite pockets, it would scale as I needed it to, as wide and broad as I needed it to. It would continue to serve, and then as my traffic died off, Kubernetes will automatically descale, will automatically start removing the instances of my website so that I'm not using extra compute power for no reason. And so this is kind of the value prop of Kubernetes, is that it automates the orchestration of these containers, that you don't have to have sort of a person in the control room all the time. Kubernetes will handle that for you. Some additional terms, container image. So The closest analogy for this in the VM world would be like a golden image for a VDI. So this is bits on a disk, but this is all of the package. This is the package of software that you would deploy to production that would get instantiated into a container. And a container is the term for a running container image. Confusing, I know, but well, that's the world we live in. So image gets deployed to production, it goes live, it becomes a container. And finally, CI/CD, continuous integration, continuous deployment. I'm sure everyone knows this term, but just to make sure, because I'm going to mention it, this is a tool that automates build and deployments of software, and in this case, container images, right? So you build a container, a developer builds a container image, they store it in a repository, and then then they submit a CI/CD job. It'll grab the container from the image, push it to the Kubernetes cluster, and then Kubernetes will, as needed and on demand, spin that up into a live environment. So your organization wants to run containers on Kubernetes. They see the advantage of it. Perhaps they're moving to the public cloud, or they're tired of maintaining a monolithic application, so they're going to break it out into containers into sort of a microservice architecture. They want to utilize Kubernetes. That's great. And the good news is you have a lot of options. There are tons of services, both public cloud. There are tons of implementations of Kubernetes. But the bad news is you have a lot of options, and you have to secure all of it, right? As Nick mentioned with some of the incidences in the CVEs, no matter where you're at, there are still misconfigurations or possibly insecure versions that you need to address, and you have to secure it all. So the summary here, and really this gets to the meat of what I'm trying to get at here, is that we have software tools running on software tools, running on software tools that we're attempting to secure with software tools, right? And the industry in general is taking this tool-based approach, right? You have AWS Fargate, you have ECS, you have EKS. There's a number of things, and we're trying to say this tool handles this tool handles this tool handles this, without, and Justin brought this up, and I think this is perhaps the most important section or part of all of this, is that we need to operationalize around that. And in order to operationalize, we need some sort of mental or conceptual model so that we're covering all of our bases, right? Trying to take the scattershot approach is going to lead to gaps, and gaps will lead to incidences. So yeah, it's a lot, and we need a model. So I have this, what I call a 9-box model, and if you're looking at the y-axis, which is top to bottom, or bottom to top, excuse me, I have what I call the layers, and these are the layers of technologies that we sort of place on top of each other that constitutes sort of a Kubernetes deployment. Really, this could apply to container environments in general, but we'll focus on Kubernetes for now. So if we're looking at a sort of more quote-unquote traditional, if anything's traditional with Kubernetes deployment, where we're looking at a data center or on-prem where you have a Windows server or a Linux server. In the public cloud, this could even refer to compute clusters. So in the Amazon world, that'd be Elastic Cloud Compute. In Google, that'd be Google Compute, right? And Azure has its compute service, right? But really, these are baselines, general servers that run software, and those have their own configurations and patches that need to be applied to help remove vulnerabilities and reduce risk. Moving up a layer, on that you install either a container host, and for the purposes of this talk, an orchestration host, which would be Kubernetes. And again, that is something that needs to be configured and patched in some cases in order to reduce risk and remove vulnerabilities. Now, in public cloud environments, we're seeing the increase in serverless environments. So that would be things like Elastic Container Service or Elastic Kubernetes Service, Azure Kubernetes Service, Google Container Engine. Those sort of remove this infrastructure layer, but we still have the orchestration host layer that represents its own scale of vulnerabilities by misconfigurations, right? You can't patch Amazon or Google's or Azure's, or I'm sorry, Microsoft software, but you can misconfigure it. And the great thing about the public cloud is it is incredibly powerful, and it gives you all of the tools and capabilities you need to run an application. The bad thing about the cloud is that it gives you all of the tools, capabilities, and power to hang yourself. So these while it's nice to think you don't have to worry about patch management, misconfigurations become the attack surface du jour. And finally, moving up, we have the workload. These are the containers and the container images. And containers are packages of software, and those software contain vulnerabilities, right? At Rapid7, we recently announced a partnership with Snyk, and within that, we have an integration with our Intel threat database. And what that gives us is a number of some really deep insights into open source package vulnerabilities. That includes Python, Java, JavaScript, Go, Ruby, and .NET packages. That pretty much covers every organization with an application ever, and all of those possible packages represent possible vulnerabilities, including the underlying operating system in the container image, including the database engine in the container image, including whatever web server you're using, et cetera, et cetera, et cetera. So when we're looking at this layer model, when we say that when a security team tells me, hey, we have Kubernetes and we need to secure it, my question is, on what layer? You need to, if you're running it in a self-hosted or in a data center or an EC2, you need to secure it at the infrastructure layer, as well as the orchestration host layer, as well as the workload running on Kubernetes, right? As opposed to, we do a little bit of this, a little bit of that. We scan container images in the registry, and we run CIS benchmarks in Kubernetes. Well, if you have a vulnerable Windows or Linux server that Kubernetes is running on, or a misconfigured EC2 server, you're still providing a foothold for attackers. So if we're looking at the why, starting from bottom to top, it's infrastructure, orchestration, and then workload. And then in the x-axis, we have this time domain. And just to call these colors don't mean anything. I just use this to differentiate visually. But the three phases are at rest, or the dormant, or as I like to call it, the dormant phase. This is when it's just software on a disk. It's just bits on a disk. Next is the deployment phase. So this is when things are getting ready to run. So this is pre-flight. This is often when things are configured. And then runtime, things are live and running. And so when we're looking at this model, what I'm digging into here is when vulnerabilities are introduced into your environment, right? And so the shift left story, and you hear this of, we want to handle all vulnerabilities exist before runtime, so that the at-rest and deployment phase. But what we need to remember, and again, I would love, and I also hate, but I love to harp on this, is that Kubernetes is in many ways a general compute engine. It's meant to run software, meaning the software that runs on it, a container, is more than capable of performing something like a wget or curl, right? They're fully capable of live patching themselves. So if you've secured all the software packages, hypothetically up until this point, and then at runtime, the container says, hey, I'm a little old. Let's see if we can find the latest version for X, Y, or Z. There's nothing other than rules. A container, at least in its own right, is completely capable of pulling up new software packages, and to a certain degree, invalidating any of the shift left assessment that you've done. So all three phases are important, and all three phases require attention. So digging in here, this is my model as a whole. So it's the 9-box model of Kubernetes deployment. Again, on the y-axis, we have our layers. On the x-axis, we have our phases, right? And then this is where the technologies sort of fit in. So at rest for infrastructure, you have Terraform, right? So this is something of configuring an environment to be able to run, right? And this is misconfigurations, and Terraform can introduce its own vulnerabilities. Then we're looking here at deployment. This is pre-flight, how you configure your Linux or Windows servers, what version you use, how you configure EC2. These are things that you need to be able to secure in order to make sure that you're not introducing vulnerabilities here. And then finally, runtime. And this is traditionally where Rapid7 has been a juggernaut. And this is where things like scan engines and identifying vulnerabilities at runtime are particularly powerful. So moving up a layer, there really isn't a not rest phase. A Kubernetes host, and this for the scope of this talk, that could also include things like a Docker host, bits on a disk on a problem. But where you're going to introduce vulnerabilities is in the deployment phase. So as you're getting to run these things, the configuration of the Kubernetes host, right, the version of Kubernetes that you're running. But then finally, once live, remember each pod and node can have their own configuration. So making sure that those policies at runtime are compliant are important as well. And then finally, digging here at the workload. At rest, this is the world of container registries or the container repository. So this is bits on the disk, or when the developer is building the repository, we can find vulnerabilities as this thing is being built. If we know that the developer is shoving in an insecure version of Python or Postgres, or an earlier version of Python, Alpine Linux with some known vulnerabilities, we can have sort of the golden images or recommended states, meaning please use this version of Alpine Linux, or please use this version of Windows Server, or please use this version of .NET, etc. So here, this is generally the space for container registry scanning. Within deployment, this is where we can integrate with CI/CD tools or ad hoc container image scans. And again, we could look for vulnerable software packages as well as misconfigurations in the container image itself. Moreover, having scanning capabilities at this phase allows you to try to catch rogue deployments, right? So the developer, for whatever reason, decided to forego the container registry because they knew we were scanning it and their app only worked on a certain version, or they just forgot. And they just submitted a job with their container image. We could catch sort of that deployment here and provide an assessment and provide visibility and visibility for the security team. And then finally, we have runtime, which are live containers. And especially Kubernetes, this can become interesting because, again, not only can you have containers that patch themselves with insecure software, but if a container has insecure software, Kubernetes will quite happily, according to scale, expose the internet or whatever to 1,000 versions or 1,000 instances of that container. So if you have a CVSS 9 vulnerability in a container and your scale spikes up so that Kubernetes has to deploy it 100 times, your attack surface grows exponentially with that. So it's important to understand not only your exposure, providing visibility into not only understanding what vulnerabilities are present, but being able to quantify exposure and understand how often has that vulnerability been exposed to the world. And so that's where runtime, having visibility into runtime, as well as vulnerability assessment of runtime, becomes important. And also, this is where we can start getting into incident detection and response, looking at ways to monitor container behavior and saying, hey, is this thing trying to move laterally on the network? Is this performing suspicious process actions, those sorts of things? So at the runtime here, this is where across the board sort of live vigilance and where the traditional security model is focused, but there's a whole 9 areas of interest here. And I kind of joke that this 9-box model is actually a 12-box model because at just about every phase, there are different remediation teams for all of this, right? So generally the workload layer, as I mentioned previously, to fix vulnerabilities or suspicious behaviors, to stop the container from performing that wget, you're going to need to re-engineer the container. And security generally often doesn't have a well-rehearsed or well-exercised relationship with developers. And so that's sort of a muscle that some organizations need to develop. Now, if you're looking at the container host, this is oftentimes the domain of DevOps. And again, that's just a whole different team. So you could secure the workloads with container image scanning and CI/CD integrations and runtime scanning. But then the Kubernetes host itself is vulnerable. It's misconfigured, or perhaps you're using an insecure version. You'll need to talk to DevOps or possibly sysadmins in order to remediate that. Finally, here in the infrastructure layer, this is the world of the sysadmins, and this is in addition to everything else, something else you're going to need to secure, and another team that security is going to have to work with in order to create a top to bottom, left to right, secure Kubernetes deployment. So finally, to get into the scary stuff, some real world example of things going wrong. This would be the infrastructure layer. We found Windows and Linux devices. There's a specific piece of malware that was looking for servers with insecure versions of Kubernetes or container hosts running. So it would scan, leverage about one of a dozen CVEs in order to gain ingress into the server, and then it would deploy a crypto mining operation to the Kubernetes host from the infrastructure layer. So basically bubble it up. Again, if we're digging into that 9-box model that I had, this is where misconfigurations and patching your server, your infrastructure layer becomes really, really important. So again, the Kubernetes host or the workloads could have been, to CI's benchmarks or as secure as they could have been, but that one break in the chain at the infrastructure layer allowed attackers to gain a foothold and bubble up to the other layers. Looking at the orchestration host layer, this is probably the most recent example. Attackers are scanning the internet for misconfigured Kubernetes clusters. Once they find clusters with their preferred vulnerability, they then would employ a remote code execution attack in order to gain control over the Kubernetes cluster, and then they would deploy a crypto mining operation to the Kubernetes clusters, right? And again, because Kubernetes essentially provides limitless compute capabilities, it's an ideal cryptojacking target. And I mean, when we're talking about damage from Kubernetes, this is a literal dollar amount damage, because they're eating compute cycles, especially even on self-hosted or cloud-hosted, public cloud-hosted environments, and that literally translates to dollars and cents. So there's actual quantifiable monetary damages to these sorts of attacks. And given how heavy these crypto mining operations can be, these could be quite severe. And finally, looking at a workload incident, and this kind of digs into the at-rest, where the shift left story takes an interesting turn in terms of scanning at rest, where researchers found that that attackers were finding legitimate projects on the public Docker hub. So for those that don't know, Docker, who's a major container solution provider, has a public repository of container images. This is sort of the NPM or container images, or the GitHub of container images, where you have things like Alpine Linux, Ubuntu. I think there's even Windows Server up there, so that developers can just reach out and get the latest version of Ubuntu Server for containers, or Windows Server, or Alpine Linux for servers. But what researchers found was that attackers were finding legitimate projects, creating clones of those projects, basically creating a false front to look exactly like the legitimate project, but the container images in their project on the public Docker hub would have crypto mining code sort of injected into it. So an unwitting developer finds that project they want to use, they pull it down, build it into their container, and deploy it to their environment, not knowing that this is actually a compromised container image, and that they've just deployed a crypto mining operation to their production environment. So this is where scanning images at rest becomes really important, because the image scanners could have detected the vulnerabilities, or could have detected the errant code and called that out, and been able to notify the organization that, hey, you're about to deploy malicious code to your production environment before you even built it. So just an example there of not only vulnerabilities in the workload layer, but also in the at-rest phase, or the shift left phase of the workload. So that's all I had.
Well, that's a lot. Thanks, Dane. Some really interesting content. Really appreciate you joining us today. I think those real world examples, I mean, as you said, they're a bit on the scary side sometimes, but that's such a great way to see how some of these solutions can apply, and also the downsides of not exploring some of these solutions, not asking those questions. So thank you very much, Dane. Now I can see that we have a lot of questions coming in for you already. Unfortunately, we are a little bit short on time, so we are going to have to keep things moving along in the EcoCast today, but do not worry. The Rapid7 team is going to get all of your questions. Dane is getting all your questions. We will make sure that the Rapid7 team is able to follow up with you after the webinar if they don't get back to you over live chat today. So please do keep those questions coming in. I do also want to point out that I put up a poll question for you all. Now these poll questions, they're so important. It's a chance to reach out directly to the Rapid7 team and let them know what information you would like to get. So if you find yourself sometimes aimlessly clicking around on a website, not sure where to start, this is how you start. Fill out the poll and they'll follow up with you, get you the info that you need, and then they can help assist and make sure that there's nothing else that they can support you with. If you're looking for more info right away, I do also want to encourage you to head to that Handouts tab. You can download the Rapid7 Service Brief Total Risk Coverage Program, protecting your web applications through the SDLC. Really interesting read, so definitely go check that out. I want to thank everyone who's filling out the poll. I'm going to leave it up just a second longer because it is time already for our very first prize drawing of the day. I hope you are as excited as I am. I love these prize giveaways. We are giving away a reminder, a $500 Amazon gift card to 3 lucky winners who must be in live attendance here at our webinar. And the first one is going to Max Eastwood. Max Eastwood, you sound like an action hero, Max. Max Eastwood, you have won a $500 Amazon gift card. Congratulations. Don't forget there are still 2 more chances to win a prize today, plus that best question gift card from each session. Okay, I'm going to move things along. So last chance to click on that poll there. All right. Well, up next, we have another incredible session. I'm so excited to introduce Jan Oftenkamp, Director of Solutions Analytics at Pure Storage. Jan, I thank you so much for joining us on the EcoCast today. Now, I know that you've got a ton of great info to cover, so I'm going to hand the mic right on over to you.
Hello, thanks for joining today. My name is Jan Oftenkamp. I'm the Director for Analytics and AI/ML Solutions at Pure Storage. Today, I'd like to share with you how we can successfully implement high-performance, data-driven, containerized workloads in support of modern analytics. Before we jump in, ask yourself, what is driving architectural change for you? For many, digital transformation has become table stakes. Transformative objectives include operational efficiency, better and more differentiated customer experience, enhanced collaboration, development of new data-centric products and services, and the development of new business models. At the root of these are efforts to modernize the technologies that the entire business relies on: data, infrastructure, and applications. High-performance computing. Whether it's traditional HPC, analytics, or AI, we tend to think of a data center room filled with rack upon rack of interconnected systems, all dedicated and tuned to a specific workload type: chained batch jobs, streaming data analytics, or other metadata-intensive workloads. These platforms are used to solve complex problems in science and research, in healthcare, autonomous driving, and security, to name just a few. Whatever the use case, these environments are generally managed by their own team with their own budget, an HPC silo within IT linked to special projects. With the advent of new directives such as ESG and maturing new technologies, this siloed approach is quickly coming to an end. Legacy data centers and infrastructure components are simply unable to keep up with the pace of data. These silos created prevent organizations from gaining a unified view of data, never mind the operational burdens placed on IT to manage and support the unique infrastructure requirements. It should come as no surprise then that customers are looking to do things differently. to shift from fixed compute capacity to elastic allocation and deallocation of resources. Compute capacity can no longer be planned for years in advance, and frankly, neither can storage. Storage requirements keep increasing in a world where yesterday's data may be tomorrow's gold, which means that customers are faced with the challenge around how to provide access to as many data sets as possible while maintaining performance and managing costs. It's well known that HPC, AI, and analytics are data-driven workloads, delivering modern inference capabilities that enable operation automation, predictions, and recommendations that augment human staff. These modern insights gained are a result of the quantity and quality of the data sets available. And this relationship defines that the agility provided to users to consume compute lends itself to the ability to access these data sets. Very simply put, one lends itself to the other. So it's not simply a problem of just compute or just storage space. It's about accessibility and performance that does not hinder the user experience as the demands increase. We need to think, therefore, about agile compute, storage growth, and scale. When you think of agile computing, the concept of containers immediately comes to mind. For many, containers and Kubernetes have become de facto tools for building, deploying, running, and managing modern applications at scale. Often referred to as cloud-native applications, they enable faster iteration and reliable delivery of enterprise software while using resources more efficiently and reducing costs. Getting on-demand access to a shared compute resource has never been easier, as demonstrated by cloud service providers. Packaging software and container images and running containers has become a standard for many, and Kubernetes has become the most widely used container and resource orchestrator in the Fortune 500. Over the past few years, HPC, AI, and analytics have begun to shift from a specialized niche approach to the adoption of a more mature Kubernetes and container technology. So containers deliver a cloud-native experience to your users while providing better resource utilization, flexibility, and portability to the business. And they are a critical part of the architecture. But there are other things that have to be considered. Let's look next at the considerations for storage. With constant data growth, a shift from the traditional distributed compute and storage model to a disaggregated compute and storage one is needed. A scalable fast object model is also needed. This shift can be seen in such applications as Splunk Smart Store, Vertica Eon Mode, Elastic Searchable Snapshots, Confluent Tiered Storage for Kafka, and Object Data Warehouses. Now you might be asking yourself, how can an S3 storage layer be considered for a high-performance architecture? Isn't S3 for archival? Well, it's true that S3 is often associated with slower performance, especially when we consider what hyperscalers offer. And the original on-prem or data center solutions also targeted archive, and frankly, many still do today. But at Pure, we foresaw the adoption of object within the distributed computing ecosystem and created a new technology with this in mind, the industry's first unified fast file and fast object platform, Flashblade. The object protocol, when looked at from a high-performance computing angle, has the benefit of being directly accessible from within the code of each job. This allows more freedom to define storage actions such as parallelism, handling of metadata, or batch processing groups of objects, and so on, all coming together with the ease of access and enabling the end user to reduce time to results. We'll dive into this more deeply a little bit later on. If one of your use cases, however, requires the familiarity of a folder and file structure, or if the shift from file to object is too cumbersome, Flashblade also provides the same predictable low latency at scale over file protocols such as NFS. So how do we go about adopting this approach? One that supports an agile as a service model. Let's start by taking a look at what can be considered legacy high-performance architecture. This architecture is often one of either multiple interconnected nodes that provide both the distributed compute and storage layer, or multiple interconnected nodes split into two tiers, a distributed compute tier and a storage tier. You might be thinking then that you can just add Kubernetes, and by doing so, we enter a more as-a-service compute model. Well, that would be true, and it's a start. But we also need to plan for storage persistence and shared access to the data sets. Now, you could deploy on the models you know today that we just revisited, and then you have a high-performance containerized compute platform with shared data access. But when using legacy systems to fulfill the requirements of data-driven workloads, we encounter issues relating to scale and performance. Legacy storage systems were not created to handle millions and billions of files or objects, all being accessed simultaneously across diverse I/O profiles. These systems fall short when handling the scale and the varied profiles, whether they are sequential, random, large or small, read or write, as well as anything that's metadata intensive. In addition to this, think about the raw bandwidth required in I/O distribution when running multiple workloads across thousands of nodes. Oftentimes, these architectures are tuned to a given I/O profile, and when that profile changes, the platform no longer performs well. To return to an acceptable level of performance, we need to retune. And every time that profile changes, we have to do the same thing again. Now, alternatively, you could use a different platform for each profile, dense and slow, small and fast, etc., but that hardly makes sense. The main issue is one of complexity and cost. But think also about the different skills needed to maintain these different platforms. Often, there is too much to be managed, optimized, and supported, and many customers cite problematic shortages of existing skills in this area. So the complexity involved, combined with the constant care required to maintain consistent performance and stability, in addition to a capacity planning and skill shortages, have tested the limits of such architectures and create a challenge when trying to deliver an agile, simple as-a-service approach. Let's round this out by revisiting protocols. We said earlier that objects should be considered for this architecture. Part of this not only because of the efficiencies object delivers, but also because there are some inherent challenges associated with legacy protocols. And by this, I mean all non-object protocols. They create added complexity. Modern applications don't need the machinery of file systems since they have their own microservices for cataloging, metadata management, authentication, and permissions. All the folder hierarchies usually just get in the way. Take NFS, for example. To provide access to a data set, I need to know the share name for the data set, but also the client system so as to create the correct export and mount rules. And on top of that, user permissions will also need to be validated. None of this seems very much like an as-a-service approach. Leveraging an object-first mindset will simplify the equation and enable a data-driven, high-performance container architecture. Within this architecture, the main data sets are presented via S3 from Flashblade. This addresses the main requirements of fast, shared access at scale. For shared access, reading a data set can be as simple as knowing the bucket name and having access to the right Kubernetes secret. There's no client or driver overhead, no cumbersome protocol management, your users can access any data set available to them. In regards to scale, what is important is Flashblade's ability to handle high concurrency, massive scale, all while maintaining predictable low latency combined with effortless management. You can start small and grow as your demands grow with confidence that Flashblade will deliver with linear scale. This seamless implementation of performance, scaled, and shared access is critical to enabling data-driven high-performance containers. Now, it's easy to forget that a fully operational application is more than just distributed workloads. We may run a Spark job, for example, submitted from a web front end and push the output to a database that is used to populate dashboards in Grafana, alongside information from a streaming event handler. This is where our Portworx software-defined storage layer for Kubernetes fits. Providing full enterprise features such as high availability across node failure, I/O profile matching, replication, and encryption, the Portworx layer simplifies the day-to-day provisioning of storage within Kubernetes. So our data-driven high-performance container architecture leverages Kubernetes storage as a service via Portworx and object datasets as a service via Flashblade. In order to deliver on modern data requirements, a storage solution needs to deliver the following characteristics. Multi-dimensional performance is the ability to deliver very high throughput and high performance to support multiple workloads at the same time. Small or large file, sequential or random I/O, batched or real-time jobs, and a large number of files and objects. The architecture should be intelligent, which means that the storage system is built for Flash from the ground up to truly leverage the performance and efficiencies of Flash. It should be simple to deploy, manage, and upgrade without requiring constant tuning. A modern storage solution must be simple enough so that the operations don't overwhelm storage admins with the mundane tasks of managing things like networking complexities when deploying the system, volumes, cluster pairs, aggregates, flash caches, or configuring replication. Maintenance operations, software upgrades, and capacity expansions are completed without disruption. It should be cloud ready, and this refers to the cloud-like agility, flexibility, and consumption choices with on-prem control. Always available is the capability of going beyond traditional platform resiliency. It is foundational software design that makes it possible for a solution to deliver high availability over multiple years and upgrade scenarios. Dynamic scalability refers to the ability to seamlessly scale not only capacity, but also performance, including metadata, number of files, objects, and more. Multi-protocol support means that a single platform should provide native file and object support without compromising performance or any functionality. For Portworx, the main benefits are increased application density per Kubernetes worker node, a consistent data plane that enables you to achieve 0 RPO, and a sub-1 minute RTO disaster recovery for mission-critical data services. Ability to modernize more apps. Enterprise-grade storage features remove the barriers against migrating certain workloads to a Kubernetes platform. And the freedom to deploy on any platform. You're no longer locked into your Kubernetes distribution or your cloud for life. But don't take just my word for it. Here are some Pure Storage customer statements. You can see they cover a wide range of benefits from reduced energy consumption to simplified management with non-disruptive upgrades, all the way to reduced time to results for the actual workloads. Thousands of customers have experienced meaningful impact to their business outcomes by moving to a Pure Storage solution. Let me share with you a specific example that resulted in a paper documenting our success in adoption of this approach. This has generated a tremendous amount of interest already, and it continues to build. Intel's Select Solution team approached Pure Storage and asked that we help them design a highly performant, efficient, and scalable Kafka and Splunk Smart Store architecture. Intel Select Solutions, if you don't know, are predefined workload-optimized solutions designed to minimize the challenges of infrastructure evaluation and deployment. Very simply put, they do the work so that you don't have to. These are validated, certified, and verified by OEMs and ODMs, ISVs, and Intel respectively. The process we would follow would leverage Intel IT as the customer to define the requirements and to provide high cardinality production data. We would build a Kubernetes test environment using generally available software and hardware. And we would deploy on a disaggregated architecture with remote object store in Flashblade. Intel chose Pure for two reasons. One, they knew we deliver high-performance solutions. And two, Flashblade was one of the first solutions proven for Smart Store. Earlier, we made the recommendation to move from legacy approaches to a disaggregated compute and storage model, leveraging both containers and fast object in Flashblade. We identified Splunk Smart Store and Confluent Tiered Storage for Kafka as a couple of those applications adopting this shift. And that is exactly what was designed and tested as part of this process. This particular architecture leverages Kubernetes to deliver compute in an agile and efficient manner, while improving resource utilization. We deployed 9 physical servers to support a single combined Splunk and Kafka cluster consisting of 62 containers. That breaks down to 35 indexers, 18 Kafka brokers, and 9 search heads. In summary, the cloud-native technologies underlying this architecture enabled systems to quickly process the large amount of data representing today's workloads, improve resource utilization, and operational efficiency. We also help simplify the deployment and management of Splunk and Kafka. A number of tests were completed, and I'm very proud to be able to share that the results delivered far exceeded all expectations. If interested, this paper is available on Intel's website. You can search on Splunk and Kafka with cloud-native technologies. When you think about all that we've shared today, please keep the following in mind. As a service is a flexible, on-demand concept that scales with today's modern workloads. Containers deliver a cloud-native experience. Embrace an object-first mindset. Flashblade is proven to provide speed and simplicity at scale as required by high-performance workloads. And Portworx enables storage orchestration for a seamless Kubernetes experience. This brings me to the end of the presentation, and I'd like to thank you once again for the time you have spent with us here today.
Well, thank you, Jan, for an awesome presentation. I love those key takeaways at the end, some really great information for everyone in the audience today. And I'm sure you guys, like me, were writing some of those down or taking screenshots. We already have a lot of great questions coming in. Before we jump into those, Jan, I put up a poll question for you all. And again, what we want to know here is what additional information would you like to get from Pure Storage? So not only is Jan sticking around to answer some questions, you'll get to ask some right now, but this is, again, a great way to make sure that you're going to get the information that you want in follow-up to the session today. So Jan, questions pouring in here. You're ready to jump right in?
I am.
Okay, great. I want to start with this one. You made the recommendation to use object storage. Is the performance on Flashblade equivalent to NFS?
It absolutely is, and that's one of our key differentiators, and it has a lot to do with the recommendation to go to object. There is literally no difference in performance.
That's great. That's, I think what obviously trying to avoid disruption. This question coming in from Brian, you answered the first part. He had sort of a two-part question. His first part was he was checking to see if Pure Storage would work with existing storage that he has, which is on-prem, so looking at a hybrid situation, and it sounded like that was a yes. His second part was asking about security and how to control the security of their data. Could you speak to that?
Control the security of the data relative to each portion of the stack?
Yeah, I'm not sure if Brian, if you want to add any clarification there, but maybe if we just speak to sort of general security.
Yeah, so that's sure enough. So, we talked about compute, we talked about Portworx, and the orchestration of the Kubernetes environment. And then, of course, we talked about Flashblade as the recommended fast object solution. So at every layer I mentioned, data is indeed encrypted.
Okay, important. Yeah, and Brian, if you have anything else that you want to dig into on that, it sounds like the answer is yes, you can create the layers you want, and all of those layers will be secure.
That's absolutely right.
Perfect. Okay. We actually got a couple of questions about size and sort of on both sides of it. We had somebody wondering, can we scale up to the levels that we need? And we had someone saying, hey, I'm a little bit on the smaller side. Is this still going to apply to me? So I'm wondering, Jan, if you could give us a little bit of information on both sides of that scalability question.
Yeah, absolutely. And one of the things I tried to make a point of is that we can start small and we can scale. I don't know that there's anything that I would consider, quote, too small. I think that's defined by the user. But to give you some idea of some of the implementations that we've deployed, we have a customer with 1.5 petabytes at 2 locations, and another customer that we're working with that will be in excess of about 3.7. And then, of course, you have many smaller implementations as well. Less than 1 petabyte, maybe 500 terabytes, maybe even less than that. But the bottom line is the experience we deliver is the same regardless of size.
Perfect. And we did get a response back from Brian, who has said you very much answered his question. So that's great.
Awesome. All right. Thank you.
Yeah, perfect. Okay, so how does Portworx accomplish near zero RPO?
Yeah, near zero RPO would be a function of a license add-on called PXDR, where we are synchronously mirroring data. This targeted typically at cross-region, campus, or over the wide area network. We have a lower level license that still takes care of HA, but it's not the synchronous replication that I referred to in this add-on.
Perfect. Okay. Well, Jen, honestly, I wish we could keep going here, and I do see that we still have a lot of questions coming in. Unfortunately, we're going to have to wrap it there. Before you leave us, if somebody is looking to jump in right away with Pure Storage, how do they get started? Where do they head?
I would say head to our website. There is a wealth of information out there, and obviously we provide vehicles for you to contact us through and take a look at our different solutions around Portworx, high-performance computing, analytics, and AI.
Perfect. Always a great place to start. And for anyone that hasn't already found this, if you do head to the Pure Storage link in your Handouts tab, it'll actually take you right to the website. You can start clicking around, exploring. You guys have some incredible resources there. I was checking them out the other day, and there's a lot of good information there, so worth exploring. Jan, thank you so much for being here to answer some questions and for an amazing presentation. It's been a pleasure.
Thank you. My pleasure as well. Bye-bye.
Bye now. All right, folks. Well, you guys don't go anywhere because we have one more session plus 2 more prize giveaways. We're going to do one of them right now. So get pumped up. Okay. For our second prize giveaway, and again, this is a $500 Amazon gift card. This will be going to Ray Leung of California. Ray Leung of California, you have won a $500 Amazon gift card. And don't instantly forget, don't forget that there's still another chance to win another one of those gift cards. And I'm going to remind you, we've got that best question asked in each session. And I do want to remind you that even if we don't read your question out during a session, there is still a chance to win. We're looking at all these questions after the fact because we recognize that we just don't have time to get to all the questions in these sessions. They move very quickly. And again, all of your questions are also going to the teams here today, so everyone will get a chance to get those follow-ups. And especially, I saw a few of you asking for like a one-on-one consultation, and you will get that, that follow-up back as well. All right, well, again, thanks to Jan and thanks to everyone who filled out the poll question and submitted a question to us today. That is just awesome to see the engagement here. And we are going to keep moving because, folks, I don't know how this happens. We are already at our last session of the day. Here we are. So our final speaker, and don't worry, we're definitely going out strong. Up next, very excited to introduce Anthony Dutra, Technical Marketing Engineer at Zerto. Thanks for being here with us today, Anthony. The platform is all yours.
Hello, everybody, and thank you for taking the time today to join me at this session. And I'm extremely excited to be talking at this summit. My name is Anthony Dutra. I'm a technical marketing engineer at Zerto, and I'm excited to share with you today data protection as code, introducing you what is really the next generation in disaster recovery, Zerto for Kubernetes. So I always like to begin at a very high level, talking about where the industry sort of is today and where it was and how IT is evolving overall. Really, back in the day, traditionally, we would look at our applications as we would look at the hardware in our data center. It was very much codependent on one another because in case an application grew, you basically had to pick up the phone, call your storage vendor, order more disks, order more compute servers. It was really more centralized and focused around the data center itself. But developers were more leveraging this waterfall approach methodology to developing applications. All right, one piece is done. Now, do we have the resources to deploy the next features or the next piece? Let's work with the IT team to build that. As technologies like virtualization and containers sort of started to be initially adopted, we really decoupled, or what I would call virtualized, our infrastructures and therefore our applications. And it started to matter less and less where necessarily these apps ran and how we were kind of hosting and giving our IT resources to these developers to build the apps that are running our business. So technologies like VMware, Hyper-V really decoupled much of the apps from the hardware itself. And you see application architectures like hyper-converged fit this new model of software over the hardware itself. And from now, where we see things moving towards, and really the power is moving to the developers themselves, is this new era of decentralized IT and applications. So many of the companies today and developers today are adopting containers for a variety of reasons, and we'll dive into that more in detail throughout this presentation. But what the main thing to take away here is the evolution of IT has shifted more to the left side, and developers are now more in control because they are quickly trying to generate these features in these apps to get that new business, through that application itself. So it's a much more rapid world that we're living in compared to the IT of the past, where the data center was a much more centralized focus. And we're seeing this through data. So this is a statistic that I was most recently shared, where companies are containerizing their applications and they're doing so by just straight up refactoring them from virtual machines, right? That sort of virtualized layer, as we talked about before, into these containers. And what they're finding out quite quickly is the fact that security and sort of data protection are still main problems that, okay, yes, we're adopting containers to be much more efficient, and we'll discuss, sort of those details as to why that is in a little bit, but we're doing so at too much of a rapid pace, and we're doing so right into production, which is causing a lot of open gaps, a lot of security concerns in terms of ransomware attacks, and the adoption to containers, to say the least, isn't that pretty. So why containers? Why sort of softwares like Kubernetes? Why are we hearing that today? Sort of what are the benefits? A lot of it comes down to the minimization of, again, that IT resources that we spoke about before. It used to be the IT, the hardware itself dictated what the developers could do. Now the developers can deploy their code pretty much anywhere, and they only wanted to run it on the most minimal hardware requirements possible. So for a business, this minimizes overhead, increases the portability and consistency of the applications across, let's say you want to go to multiple cloud providers. You can host it in many different places because, again, it's all centered around the code, which accelerates development of the app itself and dollars back into your business when new features and stuff are released. So at a very high level, it's touching on, Kubernetes and containers for business applications, right? When you refactor into these things, you're becoming much more efficient. You can scale the app much more easily, and it is just much more agile, mainly due to the fact that you are able to move it seamlessly. It's just code, right? You're no longer focused on the hardware. So what exactly are containers? You can think of a container as a standard unit of software that is just running at an isolated portion of, let's say, a server, and it can easily be moved from one environment to another. There isn't much complication in terms of, what is the storage behind it? What are we using there? We're not focused on that with a container. We just want to run the process that it is coded to run. Now, this is very simple to implement if you're just building a, very simple application, and it starts very small. But as you can imagine, as your developers create, sort of refactor these apps into these multiple containers, you need some way to orchestrate and make sure that they all play nicely and talk together. And this is where Kubernetes is really becoming the de facto standard, almost like basically it is its own way of just managing and orchestrating the containers themselves and scaling them much more easily. So with Kubernetes today, right, imagine you have taken an application, your developers broken it down into all these different containers. Now you need some way to sort of automate it, deploy it, talk about that scalability and load balancing back, to the users trying to access these applications. So Kubernetes is what offers the containerization, the orchestration to become a full application while still taking advantage of the hardware resources required, only the minimum amount required. So it's managing everything from the storage to the services and networking. But where it sort of falls short is the realm of disaster recovery backing up and that data mobility that we talked about before. Sure, it is containerized and we're able to orchestrate all these different processes to work together. But now how do we move them from one, let's say, cloud provider to another? And this is where Kubernetes is sort of struggling as a challenge. And this is why the adoption is running into this problem, because we're, again, still having to deal with the same stuff that we've dealt with in our previous iterations of our applications when they were a virtual machine, right? So there is really, into Kubernetes itself, no DR and backup strategy inherent to it. There's still persistent data within these applications, right? Netflix, although that's a fully microservices and containerized apps, still remembers your profile and what you want to watch. So there's still very much all of that to be concerned about. And then just think of all the bad actors and ransomware issues out there today that might cause an application to go down. And now that you're sort of adopting this new framework of containers and Kubernetes, well, how do we protect using that same technology, which is a little bit more nuanced than what some might be used to in the development realm, or how they used to develop previously. So really traditional data protection, when we think about that, we're thinking about old school backups, backing up to tape. It really doesn't meet the needs of this new stateless and serverless sort of developer mantra being adopted as we see applications move more towards containerization and leveraging Kubernetes itself. So traditional sort of backup format won't really work for this sort of stateless architecture. It really lacks sort of this purpose-built protection. What good is a backup of an application that is hosting your social media site 4 hours ago when your developer made updates 10 minutes ago, right? You need to have that sort of disaster recovery in place, or just that protection in place, in order to come back online to time in that application that is going to serve value dollar back to your business and not lose it. So again, it needs to fall under where traditional data protection falls short, is it's not application centric overall. So what to look for when you are considering, okay, we've containerized some of these applications, we've refactored them from our VMs, we've broken them down into many different containers. We're using Kubernetes to orchestrate them together to now build this microservice and create this app that we had before. We're taking advantage of it. How do we protect it? You want to look for something first that's purpose built. It needs to run on Kubernetes and be for Kubernetes. And you don't really care about the storage infrastructure under it, because that's just another layer of hassle that you would need to manage, or a GUI you would need to jump through in order to protect this single application at a particular point in time. So it's not very it needs to be very flexible. It needs to support a multi-cloud strategy, so you're not worried about, hey, I'm now stuck with AWS and their charges in this public cloud, when I could take advantage of services, let's say Azure or GCP. I want to replicate this same application to these other clouds, and you don't want anything sort of giving you red tape to do so. And of course, just from a performance perspective, you want something scalable that's going to be reliable, and ensure your application is up. And really, that is exactly our vision here at Zerto. And what really our goal is to take our enterprise class virtual machine replication technology and cloud data protection that we're known for, and extend it into this realm of containers and Kubernetes. And that's exactly what we've built with Zerto for Kubernetes. So Zerto for Kubernetes is a continuous backup, DR. You can do things like long-term retention and really just near synchronous replication of a application being hosted in Kubernetes to many different cloud providers or on-prem itself. So that's one thing I always love to talk about, is the fact that Kubernetes is common across all cloud providers. Again, it's the de facto software that is orchestrating all your different containers into that microservice. So being able to move it from Azure to EKS to GKE, and do so without leaving the command line, is of huge dollar value back to your business when sort of thinking about your applications themselves. So what Zerto for Kubernetes offers to these apps is that continuous data protection. Is basically always on replication. It's near synchronous, maybe about 5 to 10 second difference between each of what we call checkpoints being tracked inside of a recovery journal. We're seeing all the changes that are happening within that Kubernetes cluster and that app that you've defined, and we're making sure that you can roll back to a very specific point in time before that application either went down or you need to move it somewhere and put it up to a particular state, right, a particular point in time. So you're doing so with the granularity of pretty much seconds to minutes of moving these Kubernetes applications. So what this basically brings to data protection is everything that, a lot of stuff that just basic Kubernetes itself is lacking from a disaster recovery perspective. This is all Zerto for Kubernetes is built right into the console itself. So you, excuse me, the CLI. So you're never really leaving the command line console overall. Your developers can integrate it as part of their, workflows and say, hey, at the end of my feature updates, let me just, maybe make a checkpoint. And, if something does happen, we can just replicate it off to the second site. We know that that's already set up for us. It's application centric. Again, it's built in Kubernetes itself. So you're using kubectl to execute different commands of creating virtual protection groups. Hey, we want to make sure these pods are protected at a certain rate, but not these ones. This is what Zerto for Kubernetes allows from a flexibility standpoint. This obviously simplifies workflows. As I mentioned before, now your developer can integrate DR into their sort of their workflows themselves, and they can move it between many different clouds. So as you saw in our list of compatible services in the previous slide, if they want to move it from EKS, AWS EKS to Azure, they can, right? And they can simply use the same CLI that they're very much used to. Zerto for Kubernetes also has an analytics component to it, which I will show in the demo. And it just shows you're not managing anything through here. You're just showing, hey, this is my RPO and RTO. This is where the failover is in this process. How do I manage it? What are sort of the figures that maybe the CXO wants to see in terms of how all of this is performing from a DR standpoint. And there's a ton of integrations with APIs in order to work with and automate sort of disaster recovery strategy using this tool. So data protection as code is the main thing that is great about Zerto for Kubernetes. It is installed with Helm. You're again using kubectl, ZRT is the command, and then you basically from there define things like virtual protection groups as to what pods are being protected. You're basically taking anything that is in that Kubernetes cluster down to the config maps and making sure that it is able to be replicated and protected in a data consistent manner in case something goes down. Again, you can see from the slide here an RPO or recovery point objective of only 5 seconds for this snapshot, right? It's insane how quickly you can roll back in case of an attack, get the persistent data that those Kubernetes applications are hosting back online, right? Your application back online, serve value back to your business. These are the virtual protection groups that I was talking about earlier. Basically, you can select the specific pods as well as persistent volumes to a level of protection that, let's say you want to replicate locally, you want to replicate to a secondary cloud, you're able to pick and choose how you logically segment these different Kubernetes resources and protect them in right order, consistent, right? So it's coming back online when you need it to. Analytics for reporting and alerting. Again, this is that dashboard that I mentioned before where you can just get really good reports and really good views of your full disaster recovery environments and how, Zerto for Kubernetes or, the replication that you have set up is playing a part within it. All right, now while we have about 3 minutes left, I am going to quickly show a demo of us replicating a WordPress site hosted in Microsoft Azure to the Amazon AWS EKS service. And we're going to see that that site is, running a basic WordPress site, and we're going to hack it. We're then going to, before we replicate it, replicate it over to that AWS site and then bring it back online. in AWS itself. All right, so I'm just going to cut over to the video now. Let's see if this works. Oops. All right, so what we have spun up here is a WordPress site. You can see that the front end is hosted in one pod, and that I'll just go back, and that the MySQL server is hosted in another. It's running Kubernetes. This is the external IP address. You just saw the site there, and we have it protected in one virtual protection group right there. All right, so this is the WordPress site. It's all clean, just a basic WordPress site. There's only one post there, that's hello world. And now we're going to make sure that we checkpoint it to say, hey, all right, our app is done. This is when we want to take a checkpoint of it. So we're tagging that checkpoint. All right, so now that checkpoint of that site running in AKS is there, we're going to see all of the checkpoints, right? That 5-second difference that Zerto for Kubernetes is using. Right? We can see that we've already defined some other checkpoints there. So now that is a version of the healthy site that we have online. We're going to hack that site by, somebody left open the admin console, left it all default at the WordPress site. So now they've been hacked. And we're just going to speed a little bit up here for time. You're going to see the hacked post there. And now that we're back at the console, we're going to start what is called a failover test with that checkpoint that we defined before. This is going to replicate the WordPress site and its SQL server to the the AWS EKS service is running now in Azure AKS, and it's going to bring that site back online to the healthy point that we checkpointed. And now all we're doing is typing, just watching it. We're going to watch the process forward. So again, you're never leaving the console. You're a developer. You can just stay in the console and initiate this process right off the gate. All right. Now we're also showing very quickly Zerto Kubernetes Analytics. You can see the details of the VPG there. You can see where Zerto for Kubernetes plays in the much larger data protection strategy of your virtual machines, right? Traditional Zerto. And now we can jump over to this monitoring tab super quick and just see the process of the failover task. So I'm going to quickly cut ahead to when it cuts ahead. And it's done. So now that it has replicated to the AWS site, we're going to pull up, what are the pods running at this site. And there is the external IP for the healthy WordPress site back up and running. So I'm going to copy that and put that into the web browser. And now you can see hosted in AWS, replicated from Azure, the WordPress site that is now up and running and healthy. So that itself is super exciting. We can see that, this automation, this non-disruption of your Kubernetes application provides just a ton of benefits. The protection is built in, so you're saving your developer cycles on just a whole bunch of work. You're not locked into any vendor. As you saw, we can move between both clouds very easily, and it's very fast to deploy overall. So we covered a lot today. I know I'm a little over time, so I will wrap up. We have industry trends. We talked about how containers are being adopted. They're being adopted rapidly, and security is still a main concern. Kubernetes is great for orchestrating all those containers, but when it comes to data protection and disaster recovery, it falls a little short. Traditional data protection lacks when it comes to being able to protect these applications right down to their pod or persistent volume level. And what to look for in terms of core capabilities are these data protection as code or application-centric focused softwares like Zerto for Kubernetes, which allows for that dynamic disaster recovery capability overall. So I thank you all for your time today, and I hope you enjoyed the presentation.
Well, thank you, Anthony. That was an awesome presentation. Definitely a great way to wrap up the EcoCast. And we're not done yet. Anthony is going to stick around and answer some of your questions. I see that we've got lots coming in, but I do want to point out before we get into that, that we've got that poll up on your screen there. What we want to know is what additional information you would like about the Zerto solution. So this is a chance. Again, we're going to chat with Anthony a little bit more in just a moment here, but this poll is a great way to reach out directly to Zerto and let them know how you would like them to follow up with you, what information you would like to get. How often do we get that chance to communicate right to a team? So please do let them know what you would like to get. And Anthony, thank you so much for that presentation. You ready to jump into some questions here?
Absolutely.
Okay. I do actually want to ask this one because it's one that I happen to know you guys do a fantastic job with your resources. Andy was wondering how difficult it is to learn Kubernetes within Zerto. And to start, one thing I have to say, the Zerto resources, the A to Zerto on Kubernetes, it's just incredible. So I'm going to put in a plug for that, but I'll let you answer as well.
Yeah, absolutely. So Zerto for Kubernetes, again, is really built and designed with, again, Kubernetes first. So you already have the cluster provisioned. You're already sort of familiar with and have the resources running. It's just like a simple Helm install in order to get it as part of that sort of Kubernetes tool set and to just start using right away the second you get some licenses. So yeah, like to your point, very easy to use, but a more hands-on approach is we do just have a lab available. So check out our hands-on labs where you can just get up and running with Zerto for Kubernetes and test it out without having to deploy anything yourself necessarily, just following some steps.
Well, and okay, so that may have actually answered this question of Brian's, but I'm gonna ask this. Brian clearly went to your website and did a little research, and he's quoting you. So he says on the Zerto site, it says this: eliminate manual processes to recover, migrate, failover, and test with simple, automated, and intuitive orchestration. Love that, nice and simple. So what Brian's wondering is this configured out of the box, or do we need to set this up at the start and then it's handled by machine learning or AI?
No, that is configured completely out of the box when it comes to orchestrating things like failover tests, complete failover operations. I think my demo kind of showed a real nice setup of that, really aside from, hey, I need, setting up an Amazon AWS cluster and having all those parameters ready, and it's already running in Azure. Now I just install Zerto and replicate it to that secondary site like you saw, and you're pretty much up and running.
Yeah, that's great.
Yeah,
nice and easy.
Yeah.
Yeah. Okay, you talked about, and I'm just going to sort of clarify here, you had mentioned migration is really simple and easy. I think you mentioned sort of cloud to cloud, and we just had some questions about migrating from Dockers to Kubernetes, and I'm just wondering if we can kind of dig into migration in general. It's as easy as it sounds?
Yeah, absolutely. Because again, what you saw from that demo really kind of does show a lot. The only difference is it would be a different command to run in order to quote unquote migrate that app to that secondary Kubernetes site. But a lot of the Zerto software is just that, right? Just following simple commands in order to complete those operations.
Perfect. And I feel like I've said this to you like 4 times now, Anthony, because you answered a lot of our questions as you were going along here. So I'm going to say it again.
Cool.
You did touch on security, but we got a question about security. So I just want to give you an opportunity. Is there anything else you'd want to add? We talked about the disaster recovery and RPO. Anything else that the audience should know about security within the Zerto solution?
That at this time is pretty much what we're still going along with in terms of, hey, you suffered a ransomware attack, be able to roll back seconds before that attack actually happened. What we are looking forward to, this is way down the line, is integrating our own sort of detection of, potential anomalies that might be ransomware. But that is news to come. And yes, and then just integrations with third-party platforms. A lot of the whole Zerto for Kubernetes sort of structure around it is built around APIs. So if you have, a Zscaler, a third party that you like already, kind of integrate that into the flows of like a disaster recovery strategy. So it's nice to just, be able to execute Zerto as part of that sort of code base overall. So.
Okay, I like that. So with all of that kind of coming in and all the different elements that can be a part of Zerto, we got a lot of questions about cost. How is Zerto for Kubernetes actually licensed?
Yeah, that's a great question. We are licensed 8 vCPU per license, so we're not necessarily tying you to a number of master nodes or controller nodes that you're forced to kind of provision. It's just per 8 vCPU, and use it as you will.
Awesome. Okay. Last question I'm going to sneak in here. Can you tell us if Zerto for Kubernetes has a user interface?
So no, it does not, right? It's not, tied to a storage platform where you're managing everything through a GUI. The only kind of thing that we do have is Zerto Analytics, which I also demoed. It shows, like, alongside you have some other virtual replication going on, your RPOs, your RTOs, and gives you a little view that way. But again, yep, everything else is just CLI.
Awesome. Okay, and I want to mention that you got a couple of high fives in here, and Chris wanted you to know he thought it was a very informative presentation. You got some applause from Peter. So lots of good feedback there, Anthony. Always a great note to end on. Before you run away from us, we chatted a little bit about some of the resources on your website, but if somebody's really jumping to get started with Zerto, as I'm sure lots of our audience is right now, where do they go? What's their first step?
Yes, I always boast the Zerto hands-on labs. Go ahead, sign up, and you'll be taken right to a lab page where you can do everything from VM replication on-premise between sites to the public cloud, and again, Zerto for Kubernetes. So play with it yourself, and thank you everybody for joining. Yeah,
I love that lab idea. That's such a cool, we always say the best way to, get to know a solution is to play with it. So, get in and start playing. That's awesome.
Yeah.
Well, Anthony, thank you again so much for being here and for sticking around to answer some questions.
Of course. Thank you, everybody. Thank you.
All right. Well, and I'm going to remind you all, if you haven't checked out the handout section, definitely head over there, click on the Zerto link. You can download and read the state of data protection for Kubernetes. Really interesting reading, lots of great follow-up to our conversation here today. So go check that out. Do go check out the website and the lab. And if that all wasn't exciting enough, we have come to another prize giveaway. So our very final $500 Amazon gift card that we will be giving away in the EcoCast today is going to Saurabh Campbell. Saurabh Campbell of Arizona. You have won a $500 Amazon gift card, Saurabh. And I'm going to remind you, our three winners today were Max Eastwood of Arizona. Ooh, all warm states today. Max Eastwood of Arizona, Ray Leung of California, and Saurabh Campbell of Arizona. So not only do you guys all get to live in beautiful, warm places, now you have $500 for Amazon to spend on presumably fans and air conditioners for you all. And I will remind you that we do have that best question prize winner from each section, so we will be following up with you as well. Stay tuned. And if you are on the webinar today and you were thinking to yourself, this looks like fun, I'd like to get involved. Well, it is fun. Come have a conversation with me. So if you'd like to present on a future EcoCast or a MegaCast, we would love to hear from you. Reach out, shoot us an email at connect@actualtechmedia.com. And with that, we've come to the end. It happens faster than I think every time. I want to thank, on behalf of the Actual Tech Media team, the wonderful team from Rapid7, Pure Storage, and Zerto for making this EcoCast possible. I know that I have gotten lots of interesting insights. I hope that you have as well. This is really an exciting, always moving kind of world, as we talked about, of modern applications. And there's always more to learn here. So I hope you've gotten some good tips and tricks on how you can better support and enable your modern application environment within your organization. And I hope that you will keep those questions coming. Thank you to everyone. Big high fives if you submitted a question or answered a poll, or hey, just attended and added good vibes to the day. Well, speaking of good vibes, I do want to invite you all to come back and join me again tomorrow, Wednesday, August 10th at noon Eastern or 9 a.m. Pacific. We're going to have a chat about achieving success with database as a service. So come chat with me and DataStax tomorrow. That's Wednesday, August 10th at noon Eastern, 9 a.m. Pacific, and we will learn more about how to achieve success with database as a service. Who doesn't want to achieve success? That's a great thing to do. So come join me. We'll give you the keys to the success castle on that one. All right. Well, folks, I have to say it's been an absolute pleasure. I look forward to chatting with you all again soon. And until then, I hope you have an absolutely wonderful end to your day.